practice C, practice 16C. Is about equilibrium. Okay, equilibrium of the forces. What does that mean, equilibrium of the forces? If the forces are in equilibrium, what's that mean? They're equal. Okay, so if I've got three forces, or three charges, I've got Q1, Q2, and then I've got some charge Q3. Okay, if we're in equilibrium, then the force from one of them is equal to the force from the other one, and what would be true? What would happen to Q3 if the forces are equal? Q3 is going to stay put. Good. All right, so Q3 is going to stay put, and so it's in equilibrium. It's in static equilibrium. And so when we're in static equilibrium, the force between 1 and 3 equals the force between 2 and 3. So the two forces are equal. And when we go to calculate the force is... what's the magic equation? We've just been doing it for like 2 days. K, Q1, Q, and in this case it's going to be Q3 over R squared equals K, Q1, or Q2, Q3 over R squared. Okay, are these R's necessarily the same number? No, not necessarily. They're not necessarily the same number because we don't know exactly where Q3 is, and because we don't know how, well, we do, we'll be given that. But right now we don't know how big Q1 is and how big Q2 is. Do you see anything, looking at the equation, is there anything that can cancel? K's, the K's go away. Hey, guess what? We don't have to multiply those out. Is there anything else that cancels? Q3. So does it matter if Q3 is positive or negative? No. Does it matter if Q3 is huge or small? No. Okay? So it doesn't matter what Q3 is. So now look at our equation. It's gotten much easier already. Q1 over R squared equals Q2 over R squared. Now these R's aren't the same, so let's go talk about those R's real quick. Okay. So let's say, we'll just make up a nice easy number. Let's say the distance between 1 and 3, or 1 and 2, 1 and 2, all the way, the big distance there is 1 meter. Let's say that was 1 meter. Okay, do we know exactly where 3 is? No, we don't know where 3 is. So this distance here, the distance between 1 and 3, we don't really know what it is, but so can we call it x? We'll go ahead and call it x. If this is x, and this is 1 meter, what is this distance here? How can we find that distance? 1 minus x. That's 1 minus x. Okay? So now our equation, okay, we had Q1 over R squared equals Q2 over R squared. Now we know that those R's are Q1 over X squared equals Q2 over 1 minus X. Okay, now be careful. You need to square this. When you square this, what do you have to do? Make sure you FOIL that. Make sure you FOIL that out. Make sure you FOIL that out. Okay? This distance is not always going to be 1. In this example, it's 1. It's not always going to be 1. It's going to be whatever the distance between 1 and 2 is. Whatever it is. Distance between 1 and 2. Okay, so now let's say that Q1 is 6 microcoulombs. So let's say that this is 6 microcoulombs and this is 12 microcoulombs. I made up the numbers. Okay, what's micro mean? 10 to the minus 6. So this is going to be 6 times 10 to the minus 6 over x squared is equal to 12 times 10 to the minus 6 over 1 minus x squared. Do you see anything that cancels?
Yeah.
What?
Well, you can take out the 6 and minus 6 and then take out 1 and then change the other one to 2.
Okay, so you're going to reduce this. What if it was like 3 and 8 and that doesn't reduce? But how about the 10 to the minus 6s? Can those 10 to the minus 6s go away? Hey, guess what? We don't have to work with scientific notation. Okay, so those 10 to the minus 6s will go away. So now, how would we solve it? What would we do to solve this? Cross multiply. Cross multiply. Okay, we still have to FOIL this guy. Don't forget to FOIL that guy. Don't forget to FOIL that guy. Cross multiply. And what kind of equation do we have? We kind of alluded to, we have a quadratic equation, so we need to use a quadratic formula. With how do you when you're going to use the quadratic formula, what do you need to do to your equation first? Set it equal to 0.